Okay, on number 10, the directions on number 10 says find all points of inflection. So remember, you're going to find the second derivative and set equal to 0 and solve. Set up intervals using these values, then test intervals to see if it is concave up, positive, or concave down, negative on that interval. If the concavity changes across the intervals, then there's a point of inflection. At that x value between the intervals. So we're going to go ahead and find our second derivative. So here's our original equation, which is f of x equals 1/4 x to the fourth minus 2x squared. So I take 4 times 1/4, I get 1. I drop that by a power of 1, so that's going to be x to the third. And then take the derivative of negative 2x squared. So I take 2 times 2 is negative 4. I get negative 4x. Now I'm going to take the derivative of that derivative. So it's the second derivative. So the derivative of x cubed is going to be 3x squared. So 3 times 1 is 3. I drop that by a power of 1 is x squared. Negative 4x, that derivative is going to be negative 4. So I set 0 equal to 3x squared minus 4. Go ahead and solve that. Find out possible points of inflection. So notice I got 4 equals 3x squared. I got 4 thirds equals x squared. I take the square root of both sides. I get the square root of 4 all over 3. All equals the square root of x squared. I got plus or minus 2 square root of 3 all equals x. So I'm going to go ahead and set up my intervals. So setting up my intervals using my possible points of inflection. So I'm going to go from negative infinity to negative 2 over the square root of 3. I'm going to go from negative 2 over the square root of 3 to 2 over the square root of 3. I'm going to go from 2 over the square root of 3 all the way to infinity. Choose a number in those intervals. I got negative 2. Substitute that into the second derivative. So remember the second derivative of that equation was 3x squared minus 4. So substitute in that negative 2. So place that x and put negative 2. So I got negative 2 squared is going to be positive 4. 3 times 4 is 12. And 12 minus 4 is going to be 8. So that means that came out to be positive. So that means it's concave up right there. So substituting in a value between negative 2 over the square root of 3 and 2 over the square root of 3, I'm going to substitute in 0. So substituting in 0, I get 0 squared, which is 0. 0 times 3 is 0. 0 minus 4 is going to be negative 4. So that's negative, so that's going to be concave down. And so then I substitute in a point between 2 over the square root of 3 and infinity. So I'm going to choose 2. So substituting that 2, I got 3 times 2 squared. Well, 2 squared is 4. 4 times 3 is 12. 12 minus 4 is going to be 8. So that's positive, so it's concave up. So it looks like it did change all between all intervals. The concavity did. So that means that I've got points of inflection at those points of negative 2 square root of 3 and 2 square root of 3. Now if you want to go ahead and find the original values that find those points that go along with it, the y values, just have to remember that our original equation was 1/4 x to the fourth, and then minus 2x squared. So just take your calculators. Let's see if I can type it in correctly this time. So first off, I'm going to type in, I'm going to put parentheses around, let's clear this other one out. So I'm going to put parentheses around all my fractions. I'm going to hit alpha F1, hit my fraction key, and then I'm going to type in 1. And I'm going to put down a 4, an arrow off the side, hit that right there. And then I'm going to go ahead and type in negative 2 all over the square root of 3. So I'm going to put in parentheses again. I'm going to hit alpha F1, hit this right here. And now let's see if I can get this in correct. So I got negative 2. And then I'm going to type in the square root of 3. Arrow off to the side, put in another parenthesis there. And that's going to be all to the 4th power. And I'm going to type in minus. I'm going to put in 2. I'm going to put in parentheses right there. And I'm going to type in my fraction, so alpha F1. I'm going to type in negative 2. And then all over the square root of 3. Arrow off to the side. Put in my end parenthesis. And then hit my squared key. Hit enter. I get negative 2.2222. Hit math. Hit 1 for fraction. Hit enter. And that comes out to be negative 29ths. Now you're going to notice I'm going to do the exact same thing, only I'm going to do it with a positive. So I'm just going to go in here and change all these to positives. So I'm just going to delete out that negative right there. And I'm going to go ahead and delete out that negative over here. And hit enter, and you'll notice that in this case right here, it comes out to be the exact same answer, so negative 20/9. Okay, on this next problem, on number 11, the problem says, a farmer plans to fence a rectangular pasture adjacent to a river. The pasture must contain 245,000 square meters to provide enough grass for the herd. What dimensions will require the least amount of fencing if no fencing is needed along the river? So the first thing you want to do when you're dealing with a problem like this is draw a diagram representing the given information. So you're going to notice that he's drawn a rectangular pasture. Here's my river right here. Here's my rectangular pasture right here. And it says that he's going to use the river as one side of his fencing. And so here's the rest of his fencing right here. I got this side, and this side. I don't have to worry about the river side. So I'm going to call this side X, and the side X, and the side Y. Okay, so let's write equations for the area and perimeter and use the given information to decide which one is the primary equation, the one to be maximized or minimized, and the secondary equation of the given criteria. Substitute the secondary equation in the primary equation. Find the critical numbers and then answer the question posed by the story problem using your knowledge of critical numbers. So first off, you're going to notice I take this shape right here, and notice here's my perimeter formula, x, x, and y. So perimeter is 2x plus y. Here's my area formula, which is going to be x times y. Once I have my two formulas written down, I'm going to go ahead and look at my problem and see which one it wants to be, which one is the primary equation, and which one is the secondary equation. So my primary equation, it says right here, it says what dimensions will require the least amount of fencing. So that would be my equation I want to go ahead and maximize or minimize. So I'm using this formula right here. P equals 2x plus y is my primary equation. And then notice it says I've got 245,000 square meters is my criteria. So that would be my area. So now that I've done that, I'm going to go ahead and solve my secondary equation for a variable. So that's what I do. I take my secondary equation, I solve it for y, divide both sides by x. I'm going to take that value and I'm going to substitute it back into the y of my primary equation. So I've got P all equals 2x plus 245,000 times x. So I rewrite that as 2x plus 245,000, x is negative 1. So I can go and find this derivative, because the derivative is where the maximum and minimums occur. So the perimeter max, I take the derivative of 2x, I get 2. I take the derivative of 245,000 x negative 1, I get negative 245,000 x negative 2. I go ahead and use my algebra, just go ahead and simplify that down. So to simplify that down, remember x negative 2 goes to the denominator. So now I got 2 minus 245,000 all over x squared. So I'm going to go ahead and move the 245,000 all over x squared, add it to both sides. I multiply both sides by 2, so now I'm going to get 2x squared all equals 245,000. And I just solve that equation, and I solve for x. And when I do that, I'm going to go ahead and get x equals 350. Now that I know that x equals 350, I just go ahead and substitute that back into the original equation. So notice that this equation right here was 245,000 equals x times y. So if you take that right there, you go and take 245,000 all equals, we found out was x, 350, times y, divide 245,000 by 350, you're going to get your value of y. And so when you put that in your calculator, you'll get the answer of 750. Okay, now on this next problem, number 12, it says find the first derivative using the product rule. So to find this first derivative, I'm going to take the derivative of the first equation, which is going to be 2x, and the second equation the same, which is the square root of 1 minus x squared. I'm going to leave my first equation the same. So my first equation is x squared. I'm going to take the derivative of this right here. And if you want to, you can go ahead and rewrite this. You can kind of see it a little bit better. So this is 1 minus x squared all to the 1/2. So notice the derivative of that is going to be 1/2 times x squared, 1 minus x squared to the negative 1/2. So there's your outer times the derivative of your inner. So the derivative of your inner is negative 2x. Once I've done that, I'm going to go ahead and use my algebra to simplify this down. So using my algebra right here, I just change this to 2x times 1 minus x squared to 1/2 to make it a little bit easier to work with. So notice this negative 2 times 1/2 just becomes a negative 1. And then I've got an x squared times x, which is going to give me that x cubed. And then remember, this drops the denominator, and that's going to change that to positive. So that becomes 2x times 1 minus x squared to 1/2 minus x cubed all over 1 minus x squared to 1/2. I need to find my common denominator. So to find my common denominator, I look at this right here. Here's my common denominator. So that means that I'm going to have to take this one, which is over 1. So notice I rewrite that. And I'm going to have to multiply both the numerator and denominator by my common denominator. So when I do that right there, I'm going to go ahead and take this, and I'm going to go ahead and multiply this times the numerator. So notice, when I take this times this, that's just going to be 1 minus x squared. Because you add your powers, there's 1/2 plus 1/2, which is 2 halves, which is 1. And you still have your 2x. Multiply this together, you get all over 1 minus x squared to 1/2. And now notice I still have this minus x cubed all over 1 minus x squared. So I'm going to take this and distribute it on through. So I got 2x times 1 is 2x, and 2x times negative x squared is going to be negative 2x cubed. I still have my minus x cubed. I'm going to add or subtract my numerator, keep the same denominator. So now combining my like terms, I'm going to go ahead and take negative 2x cubed minus x cubed is going to be negative 3x cubed. That 2x stays the same. That's all the square root of 1 minus x squared. And if you want, you can factor out the x. You don't have to. When I factor out the x, the numerator, there's a common x right here. I get x times 2 minus 3x squared, all the square root of 1 minus x squared. Okay, now on this next problem right here, on number 13, it says find all horizontal asymptotes. So using my pre-calculus rules, you write the equations in standard descending form and compare the numerator leading power with the denominator leading power. So make sure you rewrite it in standard form. So that goes over here, so that becomes 3x squared plus 4. That already is in descending form, so standard form. So remember your pre-calculus rules. Your pre-calculus rules just says the following. It says the numerator power is less than the denominator power. Your horizontal asymptote is at y equals 0. If the numerator power equals the denominator power, then your horizontal asymptote is the numerator leading coefficient or the denominator leading coefficient. And then on this last one, the numerator power is less than denominator, or sorry, the numerator power is greater than the denominator power. There is no horizontal asymptote. So let's take a look at our powers right here. We're going to compare numerator power and denominator power. So notice this is the power of 2. So numerator power is 2. 2. Denominator power is 2. So that means that they're equal to each other. So that means we're going to take the leading coefficient all over the leading coefficient. So that's 4 all over 3. So your horizontal asymptote would be at y equals 4/3. Okay, then on number 14, last problem. It says the measurement of the edge of a cube is found to be 15 inches with a possible error of 0.03 inch. Use differentials to find the maximum possible propagated error in computing the volume of the cube. So remember your rules. You're going to write the equation, figure being described, find the differential, which is the derivative, using Leibniz notation. Then substitute the given information in the correct variables and solve for the information the problem is asking for. So notice, volume of a cube is V all equals S cubed. So using Leibniz notation, when I take the derivative of a V, he always writes dV, which stands for the differential of V or the derivative of V or however you want to say it. So now the derivative of S cubed is going to be 3S squared. And then you write ds, that stands for you've now taken the derivative of S or the differential of S. So now it says right here, it says the measurement of the edge of a cube is to be 15 inches. So notice that is going to be S all equals 15. So I substitute in this S for 15, substitute that in. And then it says possible error of 0.03, so that's ds all equals 0.03. So that's plus or minus, because it could be bigger, it could be smaller. I substitute that in. I multiply all those together, so I got 3 times 15 squared times 0.03. So just take your calculator, type that in. So we'll take 3, and we'll times 15 squared times 0.03. And get 20.25, and remember that is plus or minus. So the difference in the volume could be plus or minus 20.25 inches cubed.